Hey, so today we're going to talk about UA3, parallel lines and transversals. Okay, so this is just an extension of the last lesson. Last lesson we named all the type of angles that are formed when a transversal crosses two lines. Well, now we're just going to talk about the relationship between those angles when the transversal crosses parallel lines. Okay, so the idea is, how is this angle related to this angle? And how is this angle related to that angle? The alternate exterior angles and the alternate interior angles. So that's the focus. So we'll start with postulates and theorems. Now, I actually don't name them by their postulate name, but postulates and theorems are basically kind of like rules of geometry. Okay? Now, the big idea is that when parallel lines are cut by a transversal, the angle pairs that are formed, the ones we discussed in the last lesson, the angle pairs formed are either going to be congruent or supplementary. Okay, so if two parallel lines are cut by a transversal, then, and this is then for all four cases, the corresponding angles, meaning angle 1 and angle 2, are going to be congruent in this case. And you can see that if this line were just raised up, it would be right on top of this one. It would coincide. And so angle 1 and angle 2 would have the same measure. So each pair of corresponding angles are going to be congruent. Again, that's if the lines that the transversal crosses are parallel. Okay, so here we can say that the measure of angle 1 equals the measure of angle 2. Right, we can also say that angle 1 is congruent to angle 2. Okay, the next case is if two parallel lines are cut by a transversal, then the alternate interior angles are going to be congruent. Okay, and there's a pretty quick reason why. We already know that vertical angles are congruent. So let's just say we have this angle here. We know that 3 in this angle at the top right would be congruent because they're vertical. And we also know that corresponding angles are congruent. So this angle and 4 are corresponding. Okay, well, therefore, 3 and 4 just have to be congruent. Okay, so we can say the measure of angle 3 is equal to the measure of angle 4. We can also write angle 3 is congruent to angle 4. Okay, next case, the angles that are on the outside, on alternate sides of the transversal. Okay, remember every pair is either congruent or supplementary. Well, 7 is vertical with this angle, and this angle is corresponding with 8. So therefore, 7 and 8 have to have the same measure. They're congruent. Okay, the measure of angle 7 equals the measure of angle 8. Angle 7 is congruent to angle 8. All right, just two ways of basically saying the same thing. All right, in our last case are the consecutive interior, the angles that are on the same side on the inside. Well, we know that, let's say these two angles form 180 degrees, right? So 5 and this other angle. And this other angle is an alternate interior with 6. We've already said alternate interior are congruent. So therefore, if these two add up to 180, and these two here are the same, then 5 and 6 have to be supplementary, add up to 180. So consecutive interior angles are supplementary. They add up to 180 degrees. All right, so now we can apply this. We'll do this one at the top, you do the one at the bottom. We're given that the measure of angle 5 is 65 degrees. And we are also given in the diagram that these two lines are parallel. Okay, so that really tells us or gives us clues of what we need to do. Angle 6, well, 6 and 5 are vertical, so 6 has the same measure as angle 5. 5 and 7 are a linear pair, right? So they're supplementary. They form 180 degrees. So 180 take away 65 gives you what's left, and that's 115 degrees. Well, 5 and 8. 5 and 8 are in the same position in reference to their line, right? 5 is to the right and below the transversal. 8 is to the right and below the transversal, which makes them corresponding, and corresponding angles are congruent. Okay, and then lastly, 9. Well, 9 and 5, we don't have a name for those, but we do know that 9 and 7 are alternate exterior, which makes them congruent. So 9 is the same measure as 7, which is 115 degrees. All right, so you're going to do this one down below. You're given that the measure of angle 3 is 55 degrees, and you're also told, actually no, you're not, that these two lines are parallel. So we're going to say that L and M are parallel. Find the measures of 1 through 7. Okay, after you've done that one, I'll do these first 3, and then you do these next 3. Okay, so this next example, the only real difference is we have a set of parallel lines and we have a set of non-parallel lines, and it just gets a little bit more difficult to kind of sort through it all. Okay, but we're told that angle 3 is 110 degrees. Angle 12 is 55 degrees. Find each measure. Okay, so angle 1 has nothing to do with this line down below, right? So we have two parallel lines cut by a transversal. 3 and 1 are corresponding. They're in the same position in reference to their line. So 3 and 1 have the same measure. Angle 2, again, angle 2 and angle 3, they have nothing to do with this line down below, right? So they're both on the inside of the parallel lines and on the same side of the transversal, so they're same side interior. So these two add up to 180 degrees. So angle 2 has to be 70. 70 and 110 make 180. Okay, and then lastly, angle 13. Well, angle 13 is on this line down below, right? So it has nothing to do with the one on top. Angle 13 and angle 12 are on the outside. I know it's a little difficult to know which one's out, which one's in, but these are the two lines that the transversal is crossing. So 12 and 13 are on alternate sides on the outside, so they're alternate exterior, which makes them congruent. All right, so you do B, D, and F, and then we'll move on. Okay, the next example, all we're doing is introducing a little bit of algebra, meaning we just have some variables in place of a name, right? Same idea. So find the value of x, find the value of y, given that these two lines are parallel. Well, x and 65 are in the same position. They're corresponding. So x has the same measure as 65, so that's 65 degrees. X and y are consecutive interior, so they're supplementary, just like y and 65 are supplementary, right? So 180 take away 65, y is 115 degrees. All right, so you answer this question here, find the value of x and y, and then we'll move on. Okay, so in this example, we're just introducing a little bit more algebra. Same idea, same concepts. We're given two parallel lines. We have to find the measure, or find the value of x. Well, 6x and 5x plus 10. They're in the same position, again, in reference to their line. 6x is below and to the right, 5x plus 10 is below and to the right. So they're corresponding, which makes them equal. So 6x is equal to 5x plus 10. You take 5x from both sides, you get that x is 10. And in this case, all you have to do is find x and not the measure of each angle. Okay, so go ahead and do this one, set up the correct equation, make sure you can identify what kind of angles they are, and then solve for x. All right, this problem is not necessarily much different. It's more the instructions that make it different. It says find the value of x that makes m and n parallel. So the idea is they're not given to you as parallel, but what value of x will make them parallel? Well, it's the value of x that'll make these two angles supplementary, right? If they're supplementary, if these two add up to 180, then those two have to be parallel. So we'll find that value of x, and we'll say, I mean, there's a couple ways to do this, but we'll say 2x minus 25 plus 165 has to be 180, right? They have to be supplementary. So we have 2x plus 140 is equal to 180. 165 minus 25. And then 2x is equal to 40 if we take 140 from both sides. And then divide both sides by 2. And you get x is 20. Right? So if x is 20, then those two angles would have to, or those two lines would have to be parallel. Now for the fun stuff. This is more interesting because they're a little bit more challenging. I'm sure that's what you're looking forward to. All right, so this next type of problem is going to require, or at least it's going to be helpful if you draw what's called an auxiliary line. Okay, so auxiliary. An auxiliary line is just sometimes helpful when solving for unknown angles. Okay, and all it is just a line that wasn't there to begin with that you draw in. That can be helpful. Right, so we can use an auxiliary line to find the measures of E and F. Add these two measures together to find the measure of W. So I probably should have put a different diagram, like a before and after. This is what the before image really would look like, kind of like an M. Those two lines are parallel. This is 41 degrees. This is 35 degrees. And that's angle W. And the question is, what's the measure of angle W? So we draw in this auxiliary line that's parallel to the other two. And when we do that, we create, in this case, alternate interior angles, right? There's a pair of alternate interior angles right there. And then there's a pair of alternate interior angles right here. Okay, so let's do this one together. We have a pair of parallel lines, an angle R, right? And these two other angles down here, they don't really seem to have much to do with R. Well, we're going to draw in a third line that's parallel. Okay, when we did that, right, if you look here, now we just have a pair of alternate interior angles right there. Right, so we know that this angle right here has the same measure as R, so we can label it R. Well, let's look at these angles. Okay, 96 is this whole thing, but what's true about these two angles right here? Well, they're consecutive interior angles, so they have to be supplementary. Okay, remember 96 is this whole angle, so what angle is supplementary with 130? Well, that would be 50. Right? So this angle is a 50-degree angle. The entire angle is 96. So what's left over? What does R have to be? If the whole angle is 96, this piece is 50. Well, then R has to be 46 degrees. All right, so you're going to do this one. You're going to draw in an auxiliary line. And in this case, I think it's kind of clear where you need to put it. You're going to go right through 72 degrees, right? Split it up into a couple angles. And mark angles that you know to be true, or know to be congruent. All right, so you do this one. And then I've got these problems on the next page that I want you to do. They're just practice problems. They're a little different looking. But the idea is, maybe we can do this one together. Right? I mean, it appears like, well, we've got triangles. We haven't worked with triangles yet. Well, we still just have parallel lines, right? There's a parallel line. There's a parallel line. And we've got this line here. So this is 60 degrees. That's A. Okay, so even with, we take away the triangle, well, hopefully it's clear that these angles are corresponding, therefore A is 60 degrees. Okay, so you go ahead and do the rest of those. I'll check them in class. If you have any questions, let me know. All right, thanks.